Hi there, I'm Harshita Murthy, and today I'm excited to take you behind the scenes to showcase how we built our AI models and uncover how AI is enabled on the client. You will be hearing from the AI architect himself, Vivek Pradeep. But before we go there, let's talk about AI developments from across Microsoft. We are in the cusp of a technology paradigm shift as the world's most advanced AI models come together with the natural language interface, creating a completely new computing platform. And Microsoft is here to lead the journey. Let's look at some of the features to see how Microsoft Surface achieves this. I have my Surface Pro 9 with 5G here, which uses the power of AI to enhance my video collaboration experience. With automatic framing built in, the camera follows me wherever I go, whether I'm sitting or walking around. Even when I'm farther away, it keeps me in focus with super resolution. The blurring effect with AI is incredibly accurate and sharp. I could either apply a standard blur to obscure background objects or apply portrait blur, which is subtle and yet keeps me in focus. You can notice how intelligently it is able to recognize my fingers and keep my image sharp even when I move. With the eye contact feature, I appear to be looking directly at the person I'm talking to, even when I might be looking elsewhere on my computer. Audio effects like voice focus keep my voice in focus while removing any distracting background noise, such as a leaf blower, air conditioning, keyboard clicks, or anything else that might be distracting during a call. This device also has the ability to run live captions locally for maximum efficiency. Now let's get into the exciting part of this video. I'm so honored to interview Vivek Pradeep, the lead architect for hardware-led AI for Windows. Welcome, Vivek.
Thank you for having me.
So Microsoft has been on this AI journey for quite some time now. With eye gaze technology, Surface Hub 2 smart camera, and voice clarity, we have your brilliant team to thank for all these innovative developments. So tell us more about what is NPU and how does it work?
Yeah, absolutely. So an NPU, neural processing unit, is now the third processor in Windows. We've had the CPU and the GPU for a while. And those are good to do, conventional math, like CPU is good to do additions, scalar math, as we call it. And GPUs are good at doing vector math, all the graphics things that we do. NPUs are domain-specific silicon that are really tuned towards running AI models or neural networks. And neural networks are a paradigm shift in the sort of math they need. Number one, there are no conditionals. There is no if and else, which meant that you could just do a lot of math in one clock cycle. The other one is the math doesn't need to be precise. You don't need to do like floating point arithmetic. You don't need to get the decimal points right. You can just do integer math, which meant you could have lower power compute. And then the third thing, of course, is how we actually move memory, because all of these models move a lot of memory. And neural processing units, NPUs, are specialized towards running that kind of math. And so they allow us to offload, which is what we call it, the process of running these models away from the CPU and GPU on these processors.
So that's great. So you use this powerful NPU to build on Windows Studio Effects. Tell us the story behind it.
We had 15 teraops of compute on the Pro 9 5G NPU, which meant that we had this awesome opportunity in an era where everyone was working remotely to provide some delighters to our users in terms of many features. We will allow them to connect better and bring people closer together, right? And so what that meant is we had to do things like eye contact and background blur and auto framing, features that you just demonstrated. And it's plausible to expect that a user might want all of these active at the same time. You don't have to choose between eye contact and background blur. You want it all. You want privacy and you want to make a connection at the same time, and you want the camera to be latched onto you. So this is all concurrent compute at the same time. And so the NPU on Studio Effects, the NPU is what actually made Studio Effects possible.
So I use Studio Effects every day and I see how accurate and sharp it is. And I'm guessing a lot of training data would have been used here. Tell us more about that.
Yeah, no, that's a fun story. We started collecting data even before our team had heard the term NPU. And we were out collecting data from 30,000 humans all over the United States, because one of the things with machine learning that you have to really get well is to have no bias along any demographics, skin tones, hairstyles. We just need the algos to work for our customers, regardless of what environment they are or what part of demographics they belong to. And so to collect all of this data and ingest it, we were actually getting terabytes of data almost every other week that we had to go do quality analysis on and things like that. So millions and millions of frames came in. And then it was not just about collecting data, we had to annotate, right? Like for instance, something like background blur, the ML model detects what pixel belongs to your body, what doesn't. To train it, we have to take all of these millions of frames and someone has to go click on every pixel. And so we did all of this work and we were sitting on these really high quality algos, which are really large neural networks. Because all of this data meant the neural networks had to have learning capacity. And so they had to be big to be good and use all of the data well in production. It's like, how do we ship it? Because if I ran it on the CPUs and GPUs of the yesterday, it would just consume all your battery life and CPU resources. Enter the NPU, and now all of a sudden we had this catalyst that everything that we were dreaming about shipping a few years out, when CPUs became more capable, now suddenly just became viable with the NPU.
That is so great. So millions of data frames were collected to make this very efficient and effective. That is so good to know. Can you tell us more about how does the Studio Effects utilize the power of NPU to offload workload onto the CPU?
Multiple neural networks power the various Studio Effects. And some of the models are just very specific to certain effects. Like for eye contact, we have a neural network that adjusts position of your eyes. And as I mentioned, for background blur, we have a neural network that figures out what part of your body is you and what is the background. But then there are other things we have to run that you don't see but are important for our quality. For instance, you might have 3 people in front of the camera and eye contact only works on one face for now. And so, we have to keep it latched on to the primary face. Otherwise, that feature will just dance around the 3 people and it'll just be a very funny, flickery feature that nobody wants, right? And so we run something called a face tracker. We detect all the faces, we track the face. And that face tracker uses multiple points on the face to reliably keep that box consistent through the video frames. And if I ran that on a CPU, it would take 20 watts of power. Running it on the NPU, it only consumes 145 milliwatts of power, right? And that's just one neural network out of the many that we have to run at 30 times a second as you are in Teams calls all day long. And so that's what the NPU gives us.
Yeah, and what I also love about this is that all of this AI processing happens on the device versus on the cloud, which is so cool. So tell us more about the accuracy. I see you use it every day. It's very sharp. It's very crystal clear.
Yeah.
So how does the background blur effect enabled on the NPU differ from that of the CPU?
Yeah, the thing is, when we were building all of these features, this was a time when hybrid work was becoming more and more prevalent. And prior to that, things like background blur had to work well when you were in your office, on your office chair in an office setting. Now, all of a sudden, we saw people taking calls in the garages with their kids playing in the background, all sorts of scenarios. And we saw this because we were self-hosting this with Surface and looking at where we were seeing gaps in the quality of our algos. So with the neural network, with all the training data, which was a large set that we'd collected, allowed us to build a bigger and a better network. Additionally, it allowed us to actually use a higher resolution input image than a lower resolution input image. So both the fact that the networks were bigger and the fact that we could actually have a much higher input resolution, only because we were offloading the majority of the compute on the NPU, which is power efficient, allowed us to do this. The other thing is tight integration. So auto framing, it allows you to track someone like 2 to 3 feet away, right? Now, if we didn't have the NPU, we would just not be tightly integrating it, which meant that as you stepped out 2 to 3 feet away and we gave that whole frame, background blur wouldn't detect you. And we would zoom into you, really zoom into a blurry face of you, which would be really strange, right? But by running auto framing and background blur together, we are able to keep track of where we are zooming in and only feed that as input. So background blur knows that this is actually not a person in the background, but is the foreground that we need to go focus on.
Oh, that's so great to know. I think your team really perfected that super resolution. How does the device or Windows know to offload that processing to NPU?
Yeah, so the way this works is we have pre-compiled models that are built specifically only to the NPU, right? Like we ship Studio Effects only on NPU-enabled devices like Surface Pro 9 5G. And so to that extent, the driver for the NPU is already present in Windows. And so the camera driver, which is what runs the feature, realized that StudioFX is not an app experience. It's almost a feature of the device, a feature of your camera. So we bake it in the Windows camera pipeline, where we have mechanisms to detect that an NPU is present, and only then do we allow these features to essentially be exposed to the user. And so that's how this works. It's all precompiled, and the driver is already present based on the configuration of the hardware being present or not.
Okay, so NPU is clearly very powerful. How can a developer use the real power of NPU?
Onyx Runtime is an open source project that allows people to run their AI models, and it supports the CPUs, GPUs. The great news is NPUs now are also first-class citizen in Onyx Runtime, and you can go to GitHub and get Onyx Runtime for the NPU execution provider and run your model just like we did on the NPUs on this product.
That's great. What about the StudioFX part of it?
Yeah, so even folks who want to just directly leverage our StudioFX, even some of our models. So for instance, cameras have always streamed images. As part of StudioFX, if you're on an NPU-enabled device, you can get a camera image. You can also get a mask that shows which parts of that camera image belong to a person and which part belong to the background, and you can do your own background effects. And so there are public-facing DDIs. You can go look up on Windows documentation and just use our models and StudioFX and build your own toggles and experiences with them if you don't want to ship your own models. But if you want to ship your models, then Onyx Runtime is the right mechanism for you to do so.
I love how your team is really focused on developing more of these features and capabilities for the developers. That's where I see the future really being on. Tell us more about the AI on cloud versus AI on the client.
Yeah, so I think the way you want to think about this is it's not a versus, it's an and, right? So we have this notion that we talked about last year, which was hybrid AI. You want to think about your experience. Does your model require low latency? Do you need to optimize for bandwidth? How does privacy look for you? Do you need to deploy models faster on the cloud versus on the edge? So it's a trade-off. The great thing with the Microsoft approach here is you can do both, or you can go deep along one. Given that Microsoft's PC ecosystem is a diverse ecosystem, you will run your models on a device like this, which has a great NPU, and you might end up running your experience on a device that is probably from 2 generations ago, and you can fall back on the cloud. And with Onyx Runtime and all the execution providers across CPU, GPU, NPU, and Azure, we are giving you that flexibility to shift your workload as it makes sense, even dynamically.
Oh, that's great. And I'm only slightly biased here, but then I feel Surface would be a perfect endpoint to do that.
Absolutely. I mean, I'll say this. We built all of these algos first on Surface, and it continues to be our primary dev vehicle even now.
That's awesome. And the more we talk about NPU, I feel like there's endless possibilities with NPU. Give us some examples of how NPU could be used.
Yeah, one thing we already did and shipped, and if you are a proud owner of a Pro 9 5G, you'll be able to experience is the live captions feature. So Windows StudioFX is all about audio and video AI, right? Regardless of whether you're in a Teams call or using your camera app. But the other feature that we have in it is a Windows feature called Live Captions, which is an accessibility feature. It shows captions in your Windows shell whenever there's an audio or video playing on your screen. On a non-NPU device that runs on the CPUs, but on a device like Pro 9 5G, it actually offloads to the NPU. The model then runs faster, burns less power. So we can have any AI model, as long as you use Onyx Runtime and you have the right offline tools that you leverage, can be offloaded to the NPU within, obviously, the compute bounds and the memory bounds of the processor, which, by the way, is quite significant.
That is so great to know. We're just coming to the near end here. Can you close this off talking anything about how the training data was used and responsible AI? I know Microsoft is deeply committed to making and building AI models in a very responsible way.
Yeah, absolutely. Responsible AI is at the heart of pretty much all of our workflows of how we build models, all the way from collecting data to training models to validating it. For a lot of these models that we've shipped on StudioFX, we've actually gone through responsible AI assessments. For quite a few of them, we've gone through multiple iterations where we have spent a lot of rigor in measuring the impact. And the way we do this is we have, as I mentioned, a massive data set across a diverse demographics. And we assess the quality of our algos across each of these demographics in a scale way. And we've, through these iterations, decreased these disparities from where we started out with. There were like 2 to 3% disparities to like sub 1% in case of many of these algos. And we continue to iterate on it. Responsible AI is a journey where there's the investment on it continues to happen. The other thing, of course, is with the NPU, we run all of these models locally. Your data stays on device. And so from a privacy perspective as well, this is something that helps drive our responsible AI story.
Thanks, Vivek. I truly enjoyed our conversation, and thanks for providing insights into the development of AI models for hardware. I'm truly amazed by everything that your team builds, and it was so great to have you here, Vivek. Thank you.
Yeah, thank you. I enjoy talking about it. And to be honest, just representing the work of a large team here or several teams, it's taken a village to build all of this. And special thanks to Surface for leading the charge and building some amazing silicon and giving us a canvas to actually bring all of these cutting-edge AI models to our users.
It's great to have you here. Thank you.
Thank you.
You heard how Microsoft built AI on the client, enabling faster processing and better collaboration with high levels of privacy and security. Microsoft's advancement in AI are grounded in our company's mission to empower every person and organization on the planet to achieve more, from helping people be more productive to solving society's most pressing challenges. With Surface, enabling AI on the client for collaboration is just a start. Thank you.